This lesson is on factoring trinomials of the form x squared plus bx plus c. So we will be factoring only those trinomials that have a quadratic coefficient of 1, meaning you'll have just a plain x squared or y squared, but you won't have like 3x squared, 4x squared as your first term. Okay. First of all, to start off, when we're factoring, factoring is writing a polynomial as a product of prime polynomials. So here's an example that I have right here. I have x squared plus 16x plus 28, and if I write it in the factored form, it's going to be x plus 14 times the quantity x plus 2. So why is that the case? Both of those are equivalent expressions, is what we call them. They're equivalent. They have the same value. If I plug in x equals 2, they equal the same thing when I simplify it. This is considered simplified. That's a simplified polynomial written in what we call descending order. I have the highest degree first to my constant at the end. Okay? This one is considered the factored form. It's written as a product. Okay? I'm taking the quantity x plus 14 times the quantity x plus 2. Now, if you remember from when you were multiplying binomials, or you were multiplying polynomials, we did something called foiling. So if I take this example here and I FOIL, I take my first terms, x times x, I get x squared. And then I take my outside, x times 2, which is 2x. And then I take my inside, 14 times x. And then I take my last, I get 28. And when I combine my outside and my inside, I'm going to get x squared plus 16x plus 28, which is exactly what I had in the simplified polynomial form. So they're equivalent. One's just considered factored, and the other one is considered a simplified polynomial. So let's do a couple examples of factoring here of this form where I have a 1, x squared, y squared, k squared, whatever my variable is. So my goal is to write this problem as something times something. Okay, so when I FOIL this, I'll end up with what I started with. We're just going backwards. We're going, instead of multiplying, we're actually factoring it. But it's just the backwards process. The way I do this is I do kind of a guess and check. Okay, so I look at this, and if I'm going to FOIL my first terms, then this term and this term need to multiply to give me y squared. So I know this is going to be y and y. And this is why this is the easier type of factoring of trinomials, because I don't have to really worry about that first term. Okay? Then my next term, this times this, needs to give me that negative 10. Okay? But also, I need to have this times this and this times this to add to give me negative 9y. So how am I going to go about finding these two numbers? Basically, I'm looking for two numbers to fill in that red spot, so that when I multiply my reds, when I take these two and I multiply them, I'm going to get my negative 10. And when I take this times this plus this times this, I'm going to get my negative 9y. So what I do is I basically, in this situation, find two numbers that multiply to equal negative 10 and add to equal the negative 9. The y is going to come into play because I have the y's here. Okay? So if I look at my problem here, I have what multiplies to give me negative 10 and adds to give me negative 9. So if I'm trying to do this, I have multiplies to give me negative 10, and I usually just write m equals and a equals negative 9. I'm going to look at my factors of negative 10. I have 1, 10, 2, and 5. Okay? I also need to look at the fact that I have multiplies to give me a negative 10. So since it's a negative, I know I'm going to deal with a positive and a negative number here. I cannot deal with two positives or two negatives because they would multiply to give me a positive number. And they also need to add to give me that negative 9. So my larger of the two numbers is going to be negative. So when I add them, I end up with a negative number. So when I look at this, my only option here is going to be the 1 and 10, with the 10 being a negative. Okay, that way, when I multiply 1 times 10, I get negative 10. And when I add 1 plus negative 10, I get negative 9. So when I go to my problem here, I can either put a plus 1 here and a minus 10 here. Or I could write this as y minus 10 y plus 1. Since I'm multiplying, the order doesn't matter. Multiplication is commutative, so I can switch those factors around. But you will notice if I want to check, I take y times y, I get y squared. Now, I'm going to do my checking with the outside and the inside in one turn, so I'm not going to take as much time. I get 1y and negative 10y, which gives me negative 9y, and then negative 10 times 1 gives me negative 10. And you can see that that equals what I started with. So my factored form is either this one or this one. Okay. Okay, let's do another example. Here I have k squared plus 9k plus 20. So once again, I'm going to find my two numbers that multiply to give me 20 and add to give me 9. So if I look at my factors of 20, I have 1 and 20, 2 and 10, 4 and 5. Okay? Since multiply to equal positive 20, I'm dealing with either 2 positive or 2 negative. But I'm adding to give me a positive. So I know I'm dealing with two positives. And if I look at my factors over here, I can see that 4 and 5 are going to be the ones that are going to multiply to give me 20 and add to give me 9. So let's come up with our factors here. Since it's k squared, I'm going to have k and k. My two numbers that I figured out were plus 4, positive 4, and a positive 5. So I have k plus 4, k plus 5. Or once again, I can write it with k plus 5, k plus 4. Okay. Can I check this? Sure, I'm going to check it real quickly over here. K times k is k squared. I have 5k plus 4k, which is going to give me 9k, and 4 times 5 is 20. So I know for sure that I factored that one correctly. Here's another example, a basic trinomial with the 1p squared. So once again, what multiplies to give me negative 38 and adds to give me negative 17. So let's look at our factors of negative 38. We have 1, 38, 2, 19, 3 doesn't go in, 4, 5. I think that's it as far as our factors. Since we're multiplying to give me the negative and adding to give me a negative, I'm looking at a positive and a negative number. Which one is going to be our largest number? The negative. So that I make sure that when I add them, I do get the negative 17. So when I look at my two different possibilities, the only one that's the option is going to be 2 and negative 19. So what are my factors? P plus 2, P minus 19, or P minus 19, P plus 2. And once again, real quickly, we can check by multiplying it out. When I multiply it, I get p squared minus 19p plus 2p, which is minus 17p, minus 38. So I know for sure I'm right on that one as well. So let's look at this next one. You'll notice I do not start with a basic m squared. I have a 2m squared, but the first step of factoring is always to factor out the GCF. And if you look at all of my terms here, I have 2m squared, negative 6m, and plus 10. So 2 is going to factor into all of those. I'm going to take out a 2 first. And now I have a trinomial of that form that I'm looking for, where I have a basic m squared. I don't have a coefficient before that term. So when I do my multiply to equal, I'm going to use what's in the parentheses. I can ignore the 2. The 2 will be in my answer, but I don't have to worry about it when I'm doing my factoring. So it multiplies to give me a 5 and adds to give me negative 3. Okay? So I go through and then I'm looking at my factors of 5. I have 1 and 5. And that's it. And I also know that I'm going to have 2 positives or 2 negatives. In this case, I'm going to need 2 negatives to make sure that they add to give me negative 3. However, if both of these were negative, they don't add to give me negative 3. So in this particular case, this factor right here, this polynomial right here, is what we call prime. I can't factor it any further. That's as far as I'm going to get. So my factored form is just going to be 2 times m squared minus 3m plus 5. And that's as far as I can go on that particular problem. You'll notice on this next example I have two variables. I have the u squared and I also have a v squared at the end. But my middle term has a uv in it. So what's going to happen when I write my factors here is I can write them if I want to right away. I'm going to have a u and a u here to get the u squared. And my last term is going to have a v in it. So when I FOIL this, I'll get the v squared at the end. And then in the middle, what will happen is when I take the u times the v, whatever number is in front of that v, I'm going to end up with uv. And v times u is still going to be uv. So I will get the uv that comes in the middle. So my process is really the same. I just need to add that v on to the end. So I'm going to find two numbers that multiply to give me 49 and add to give me negative 50. So because it's multiplied to give me a positive, I'm dealing with two positives or two negatives. In this case, because it's adding to give me a negative 50, I'm looking at two negative numbers. Let's look at our factors of 79. 149, 2, 7, and 7. Okay, so the only ones that are going to work here are 1 and 49, but they're both going to be negative. And I'm going to end up with minus 1b minus 49v. Now I don't need to write the 1v, but I'll write it that way. Okay, so if you look at this, what's going to happen when I FOIL this, when I check this, I'm going to get u squared. And then when I take this times this, I get negative 49uv and minus 1 uv. And then the negative 1v times the negative 49v gives me positive 49v squared. So I get that middle term that I was looking for. And I get the v squared at the end. So I know that these are my factors of u squared minus 50v uv plus 49v squared. Now this last example is kind of a good question so you understand the idea of factoring. Write all integral values. Integral means that we're dealing with integers, negative 2, negative 3, negative 4, 0, 1, 2, 3, and so on. No fractions or decimals, for which the trinomial can be factored. So if you think backwards, remember, I need to come up with these factors where I have z and z. And these two numbers right here have to multiply to give me 12. But this times this and this times this have to add to give me k. Okay? So I want what multiplies to give me 12 and adds to give me k. What are possible values of k? Well, what are my factors of 12? I have 1, 12, 2, 6, 3, and 4. So what could I get for values of k? Well, if I add 1 and 12, my k could be 13, it could be 8, it could be 7. Because it's a plus 12, I'm either dealing with both positive or both negative. So I could also have a k here, if these were all negatives, I could have, I'm just going to put plus minus, plus minus, plus minus. So that if they were all negatives, I'd have negative 13, negative 8, and negative 7. So my possible values of k are going to be those 6 values. Okay. How about this next one? What I have what multiplies to give me k and adds to give me 9. In this case, my k is positive, so I'm only looking at positive values of k, okay, not negative k's. So let's be careful with that. Okay. So if I look at this, what adds to give me 9? I have 1 and 9, not 1 and 9, 1 and 8, 2 and 7, 3 and 6, 4 and 5, and then I can go 5, 4, but that's still going to give me the same values of k. So my k here could be 8, it could be 14, it could be 18, or it could be 20. In all of these cases, I'm going to come up with some factors that give me, when I add them, give me 9. So some things to remember as you're going through the factoring of trinomials of this form. The first step, always check out the GCF. So no matter what type of factoring you do, if there is a GCF, a greatest common factor, you need to take that out first. It'll make not only the factoring easier, but sometimes you won't be able to factor until you take out that GCF. The second thing is to watch out whether you have positive or negative numbers. So the multiply to equal and add to equal, having a negative in either one of those is going to change things, so be very careful for that. And the last step is to make sure you check your factored answer by foiling. You don't have to write out that work, but you should check it at least in your head, quickly check, because it's very easy to come up with a +2 instead of a -2, and that changes your answer. And if you're using the factoring in an application problem where there's more steps, that +2 instead of a -2 is going to ruin the rest of your work. And it's easy to check, it's fast to check, it's something that you should do on every problem.